Computers provide a way to actually perform the simple random experiments such as the one we did before. Pick a bead at random from a bag or an urn with 3 blue beads and 2 red ones. Random number generators permit us to mimic the process of picking at random. An example in R is the sample function. We demonstrate its use showing you some code. First, use the rep function to generate the urn. We create an urn with 2 red and 3 blues. You can see when we type beads, we see this. Now we can use the sample function to pick one at random. If we type sample beads, comma 1, in this case we get a blue. This line of code produces one random outcome. Now we want to repeat this experiment over and over. However, it is of course impossible to repeat forever. Instead, we repeat the experiment a large enough number of times to make the results practically equivalent to doing it over and over forever. This is an example of a Monte Carlo simulation. Note that much of what mathematical and theoretical statisticians study, something we do not cover in this course, relates to providing rigorous definitions of practically equivalent, as well as studying how close a large number of experiments gets us to what happens in the limit. The limit meaning if we did it forever. Later in this module, we provide a practical approach to deciding what is large enough. To perform our first Monte Carlo simulation, we'll use the replicate function. This permits us to repeat the same task any number of times we want. Here, we repeat the random event 10,000 times. We set B to be 10,000, then we use the replicate function to sample from the beads 10,000 times. We can now see if in fact our definition is in agreement with this Monte Carlo simulation approximation. We can use table, for example, to see the distribution. And then we can use prop.table to give us the proportions. And we see that in fact the Monte Carlo simulation gives a very good approximation with 0.5962 for blue and 0.4038 for red. We didn't get exactly 0.6 and exactly 0.4, but statistical theory tells us that if we make B large enough, we can get as close as we want to those numbers. We just covered a simple and not very useful example of Monte Carlo simulations, but we will use Monte Carlo simulation to estimate probabilities in cases in which it is harder to compute the exact ones. Before we go into more complex examples, we still use simple ones to demonstrate the computing tools available in R. Let's start by noting that we don't actually have to use replicate in this particular example. This is because the function sample has an argument that permits us to pick more than one element from the urn. However, by default, this selection occurs without replacement. After a bead is selected, it is not put back in the urn. Note what happens when we ask to randomly select 5 beads. Let's do it over and over again. Let's do it 3 times. This results in a rearrangement that always has 3 blue and 2 red beads. If we ask for 6 beads, then we get an error. It tells us you don't have enough beads in here to get 6. This is because it's doing it without replacement. However, this function, the sample function, can be used directly, again without the replicate, to repeat the same experiment of picking 1 out of 5 beads over and over under the same conditions. To do this, we sample with replacement. After we pick the bead, we put it back in the urn. We can tell sample to do this by changing the replace argument, which defaults to false, to true. We do it like this. And when we do this, we see that we get very similar answers to what we got using the replicate function.